Hi, Arkadi.
Hello, Peter.
Thank you for joining. I invited you to a challenge.
Yeah,
Are you
thank
are
you.
you ready for it?
I'm not sure if I'm ready for challenges, but I'm happy to support and to participate. I'm excited.
Yeah, it's a new concept I'll try. I have found some technology, some manufacturing method for materials to be made, and I would like to show it to you. Then I'll ask you what is the purpose of it. And later I'll ask you if you believe that it exists in the real world. And the concept is you have never seen this before. Uh, and therefore, hopefully, you won't guess it. But then next time, it will be your turn to challenge me.
Okay, sounds
So,
good.
yeah. So I have prepared a small presentation. And I'll just share that with you. There we are. Now, you see it.
Yeah,
Yeah. Do you know this technology? So,
I don't know yet.
no. The first thing is there's some production method called spray forming.
Yeah,
And when you spray form, you can deposit a layer of metals with a production rate of 80 to 100 kilos per minute. So you have it directly in the melt, you pour it, and in this case, the layer is deposited on a steel bar. And what is deposited here is stainless steel onto carbon steel.
mm,
And you can see here it's made. And if you look at the end cap, you can also see the difference in material. You can see there's the inner, the original, and then the layer on the outside.
okay.
So so this is a extremely high rate layer deposition process, a lot more than you work with traditional when you work with laser.
Okay.
Yeah. Then the other method is to turn it around. You take a tube of stainless steel and then you cast low alloy carbon steel into it. So this is an example. This is the section where it's stainless steel, and inside there's this casted. And you can see here the matrix of the material, and then there is a short decarburation zone in the interface, but the carbon steel on the inside look pretty good.
Mm.
Uh, so these are the manufacturing methods. Do you have some ideas what materials like that could be used for? So carbon steel on the inside and stainless steel on the outside in big volumes.
So for me, first, what I think about the carbon steel and stainless steel, it's probably for some kind of oil and gas applications, oil transport, gas transport, where you need to protect, or in opposite, depending, of course, how aggressive media you have, because if you have a carbon steel inside and there is like oil flowing, you will after a certain time get rid of your carbon steel tube anymore. Yeah. So probably for something where you have, yeah, it's still more or less related to piping, I would say, because it
Mhm.
has to be cheap.
Yeah.
Maybe it's for the cables which go underground to the factories or something similar like that. And the outer rim structure gives you a corrosion protection under earth, for
Mhm.
example.
Yeah.
Might be an option. Maybe it's for, yeah, probably this is what I would call for the first case, where you need something cheap, where you can put cables, and outside you need to protect against the environment. And
Mm.
then due to a large amount of kilometers you have to cover, probably you do this exactly to save the costs. I mean, like I'm pretty impressed about this because it's basically yeah spray casting, yeah,
Yeah.
more. as it was looking for free 30 to 100 kg per minute. It's a crazy number. I would of
It is
course
pretty good.
I would question, of course, what about the bonding strength? I mean, like I
Mm.
see based on, but the question is it really metallurgically bonded? What about porosity, cracks formation, and so on?
Yeah.
I will be honest, I'm not aware of this method, so it's for me pretty cool. I don't see it as a competition to what I do, but
Nope.
it's cheap. And if we look at vice versa, that's probably where, again, you have something which inside the tubes is quite aggressive. So might be some kind of chemical liquid or whatever. That's why you have stainless steel there. And then on top, you need to save cost probably, but get a certain shape. So it's anyways, in my opinion, really the core would be that you reduce amount of expensive material by compensating it by carbon steel or let's say milled steel, something cheaper, to have a total net value in, I would say, cost saving.
Yeah, you are pretty close. Because the problem is that rebars are made in carbon steel.
Yeah.
And they corrode a lot. And some places in the world, especially US, maintenance of bridges has been forgotten for many years. So now the Americans, they are looking at expenses of $8.3 billion annually just to
Wow.
repair their worn out bridges.
Yeah, it's crazy number. And it's only
Yeah,
in, I think Germany has also a large problem with this.
yeah, it
Considering
could
the
be. Yeah.
rich falls in Dresden last year. I'm
Mm,
not sure if you're aware of this case.
no.
Yeah.
So the idea was instead of using rebar as is,
Mhm.
it's because rebars they are rolled, hot rolled, out of bars this size.
Mhm.
But then if you coat a bar this size and you roll it down to rebar size, then you have a thin layer of stainless on the outside that protects it against corrosion attacks, like you see on these photos.
Yeah.
Mm. So, do you think it is used today out there, or is it too expensive to do this?
I would consider that it's still too expensive, and that's my opinion.
Mm.
It's still an expensive material. And secondly, because what you showed to me, it's in a salt water primarily. And
Mm.
non-stainless steel will survive long enough in a salt water because in this case you would probably need to go to superior material, which might be Inconel, and in this case it gets even more expensive. I might be
Mm.
wrong. Maybe some smart guys use it already for
Mhm.
that type of application, but I would say it's still more expensive than cement
Mm.
with a metal core and then repair.
Yeah. Uh, Then some fun facts. There are existing solutions.
Uh-huh.
The first one is, yeah, you can buy galvanized
Yeah.
rebars. That is pretty cheap. You can also buy epoxy coated rebars.
Epoxy coating. Okay.
Yes.
But this is not sustainable.
No. And then finally, in fact, you can buy pure full dense stainless rebars. So talking pricing, this is crazy.
Yeah.
So, but there are some. You can see the Highway Agency advice and note. So there are some regulations now
Uh-huh.
uh, saying that you need to build it with stainless steel rebars. So price is not the issue for this. I don't know why it never turned into success. But there absolutely must be a hole for it in the market because it's not as expensive as pure stainless rebars. If you can make the core on standard steel, and furthermore, if you go carbon steel in the core, you can still have the mechanical properties you do with stainless steel or with carbon steel compared to the stainless. Because if you want to have stainless with a high strength, you either need to cold roll it to pretty high tension, or you need to go into some of the more expensive alloys.
Mm.
Uh, there must be a market out there, but I have not been able to find the companies that I knew of did it. They do not exist any longer. So it's
And did you have a contact person to ask what really happened? Is it overestimated? Maybe exactly. It's also written here that the welding might be a factor, because in this case probably you have a weak position in the whole structure.
Yeah, I don't have contact to anybody longer, but it could be interesting also if somebody views this video. If they know what happened to it, it would be wonderful to write below the video what has happened.
I'm excited. I'm actually never thought about this application from any coating way. Yeah, galvanic, I can imagine it's very cheap, and it's also from a where the corrosion protection might be even better than the stainless steel, and it might have an advantage. A combination, why not? Especially if you, as you introduced, you have this type of volume. The question is, of course, what is the diameter of those ribs?
Yeah.
How easy it's to put this process, because what you showed on the first slide, it was looking for me like a large diameter tube.
Yes, it was pretty thick. This one. So
Yeah,
so
correct.
this was the raw material that you are going to mill afterwards. So you can see the layer thickness here is a few centimeters.
Yeah.
But then when rolling it down from 200 millimeter down to 15, then you reduce the layer thickness from 2 centimeter maybe down to half a millimeter.
Yeah, might be not enough.
Hmm.
From a corrosion perspective, because again, salt water is quite aggressive.
Yeah.
I know examples actually from your North countries, Sweden, Denmark, and Norway, where especially the houses which stay close to let's say seaside, all the screws inside the houses get corroded within a couple of years, simply because you have much I say salts in the air.
Just in the air.
What to say if you located in these sea conditions? Yeah, so I'm not sure about if stainless steel half a millimeter would be enough for that application.
No, but I think it will work because when it's still protected in the concrete, the concrete itself gives a quite high pH, so it brings the iron into passive area. So it's only if water penetrates you can have risk of local areas. But if you have stainless steel, it's not open. These failures are when it's gone wrong. This is when it's.
This is what I agree with you. In this case, of course, you get an improvement, a strong improvement. The question is, of the costs for that are still within the need and what you can feel. But in my opinion, of course, it's probably good to calculate and deep dive there. It might be a very interesting application for this technology, and I consider that this 8.3 billion is a good number. If it's on
it is.
repair costs, let's be honest, my whole company who is doing only wear protective coatings is far behind 8.3 billion. And then if technology enables that, that might be interesting. And if it's again cost attractive, then yes, I have not enough data currently to disagree or agree with you, but it would be great if somebody who listened to us might put their opinion what happens to these companies like. And Anton is also This company is called Outokumpu, or
Yeah, it's a stainless steel company producing stainless steel rebars. And maybe another reason why this doesn't work in the market could be that there are regulations or standards, because they are referring to some standards saying that in this case you have to use a stainless steel rebar. But if this standard is not flexible and can accept a stainless steel coated rebar, then you're not allowed to use it. So it could be the reason why you don't see it on the market is that standards are blocking it.
yeah, especially if the standards is like 40 years old or more.
Yeah,
When the coating technologies were not so advanced,
exactly. Yeah.
might be a good argument for that. We experience this quite commonly, especially working with quite laggard market directions, including steel industry, let's be very honest, which is pity because technologies and innovation and progress are really blocked there. Might be that if there is an idea of norm behind, you can deep dive. I know for laser cladding, also for, let's say, oil and gas, which is, let's say, much more critical field of applications. Laser cladding, for example, 15 years ago was also not allowed to be used in oil transport, let's say, parts. And then you really needed to work hard, and I know people in Europe who worked hard on that, to allow laser cladding with inconels, for example, replace conventional welding with a thinner coating thickness, which was sustainable and gave you much higher corrosion protection. Might be that here it might be the case as well.
Yeah, it could easily be.
Yeah.
Yeah.
The question is, if you I mean, like, as I understood, you can roll them out, yeah. But because if you use those diameters directly and you put, let's say, high volume of very hot material on it, what happens with this part? Is it distortion still a question? How long they are, and so on and so on. So maybe details about production and manufacturing beyond only having this spray casting might be expensive, or might there some be limitations? I don't know.
Yeah, it could be. But just some resources that I found to inspire me, and then to say thank you to the people who did the work behind it.
Peter, I have a question to you.
Yes.
How you came to this very fancy technology?
I've been working with spray forming in my former life. That's also why I have this spray forming tie. It's one of a kind. And there I made tool steel, but I met some of those people around the world who worked on it. There was a spray forming conference biannually in Bremen, and it was fantastic to meet people and share knowledge. And there I met these Americans who did it. They had bought the spray forming plant from the American Navy, because the Navy, they built it because they wanted to make the tubes for the missile on a submarine with spray forming. So after they used it, they sold the plant to this company who wanted to make the rebars.
That's cool.
Yeah, so
I'm wondering if it was successful to use it for tubes for submarines.
I don't know. They never told about it. I think that was a secret.
The question is, do we have this type of technology in Europe? Are you aware of it?
We do have spray forming, but I don't know if it is running on a substrate or is it in free form. Those I know are working in free form, There's a tool steel in Denmark. There's somebody working with aluminium alloys in Germany and France. And there is a company working with copper alloys. I think it's in Switzerland. There are some activities still going on with spray forming in Europe.
Good.
Yeah.
I probably I need to deep dive on this technology because it's interesting.
Yeah.
Thank you for sharing with me, challenging me.
Yeah.
It was
Thank you.
fun.
Yeah. So
for
next
those
time
who-
it's up to you now.
I will prepare something for you as well, something fun. For those who is listening, if they decide to go and to make a business there, don't forget about Peter and give him his benefit out of that as a consultant.
Yeah, please.
Because this would be fair.
I really hope you enjoyed it. It was great to challenge Arkadi, and I am looking forward now because he's going to challenge me the next time. And he is talking about going live to ensure that I'm not able to prepare anything. If you are interested in following such an episode live, please let me know. And if you are interested in giving ideas, please contact me. Don't contact Arkadi, but send your ideas to me. What kind of challenge I should put him up to? I would love sharing it with him and make it difficult for him. So thank you very much for joining. See you again.